Hello everyone. So you would not believe that for recording this video, I have actually initiated the record button or pressed the record button at least 4 times, 3 times in a row, and 2 times here because of some setting issues that I find in OBS. So I might have to buy a MacBook in order to continue the session, but that time tells. And in this video, what we are going to do as everyone by far now that I have aced my CCNA and it's time to do something more courageous. And for that, I started studying ENCOR by the same guy which I studied CCNA, which is Jeremy IT Lab. With due request, I uh, request you to visit this guy's channel, Jeremy IT Lab. I may copy this link to the video description here. And after going through all of its video, because right now it's 59 videos here in the anchor part, I have summarized some notes. One second, I've again missed this thing. So if I switch to my screen, and now you can see that after summarizing this anchor playlist, which is comprised of 59 videos right now, I have created a note list which consists of 628 lines to be exact. And in this video, I am going through over all the 68 lines, what the expertise or the difference that I find from CCNA in CCNP. So we'll see all over that. So in order to make you this visible, let me zoom it. Yes. So starting from the very first video, if I control and click the link, I'm very sure that a link will pop up in the web browser. Let me minimize it and open a Firefox. And if I control A, sorry, if I copy it and paste it on tab, we will jump to that video in which from which I have pasted or read this content. Okay, so this is the introduction that what is actually CCNP, how it is different from CCNA, and we do have two forms of exam or two exams in covered in CCNP. First is ENCOR, which stands for Enterprise Core, and while the second is concentration exam, in which you have to decide that what you want to do in networking, means choosing a specialization. So we have NRC, which is Cisco Enterprise Advanced Routing and Services, ENSTWI, which is SD-WAN Solutions. Then we have SLD, which stands for Enterprise Network simply. Then WSLD, Wireless Enterprise Network. Then WLSI, which is Wireless Networks Enterprise. There's very much confusion there, but I'm very sure that I will be moving towards some kind of data center stuff. So I will quickly check CCNP data center. CCNP data center. I will be going to this certification. Okay. But in order to have this kind of specialization, you first have to complete or ace this enterprise core anchor specialization. So without any further delay, let's move to next video. These are some credentials regarding the CML labs that I've been setting up on this computer, which I set up on VM workstation. You can also do the same. You can take the help from the Jeremy's IT lab video. Here is my CML lab. CML lab. Okay, I won't turn it off, otherwise my video will become janky because of the less resources I have on my computer. So moving on the second video, we have learned that switches have ability to buffer frames, hence prevents collision. What is meant by buffer frame? The buffer frame is the ability to hold the frame for a specified period of time. Wait a second. Wait a second. Sorry for the interruption. So where we were about buffer frame. What is buffer frame? The buffer frame is a switch's ability to store frame for a minimal period of time before sending it out in order to prevent collision. The collision is a time period when multiple packets of frames actually collide with each other, okay, and making the data corrupt. Next, what is MAC addresses? And MAC address is the burn-in address that is found on device, and these are equally divided into OUI, which stands for Organizational Unique Identifier, and half of the address, the last what is the half of 48 bits? 24 bits. The last 24 bits defined as NIC address, Network Interface Card, specific, okay. And switches fill the MAC address table only by source address, which is a great thing to know. It's also a question in CCNA examination. Next, default MAC address aging time is 300 seconds, which counts up to 5 minutes. Next, we have a few commands from Cisco iOS, which is show MAC address table. We only in CCNA, up to CCNA, we were only limited to show MAC address table. But this time we learned about the setting of aging time, learning, dynamic, count. We have just filtering the MAC address table in order to view the specified configuration. We can change the MAC aging time by this command, or MAC address table learning VLAN, or we can filter the MAC addresses specific to a particular VLAN, etc. We can clear the dynamic MAC entries, etc. Okay, and this is the bash command to change some Linux configuration. Don't worry about that. Next, XOR. What is XOR? So XOR is as a binary arithmetic, I guess you can say. If two bits are same, the result is 0, while if two bits are different, the result is 1. So X stands for negative, or is either one of them. If two bits are same, then the result is 0, because if two things are same, the answer should be 1. But because we are using XOR, the X stands for negative, hence the answer will become 0. And if two bits are different, the result is 1. Okay, so negativity only applies when the things are same, and it is used to compare the source and destination IP addresses. Okay, next thing is and if two bits are same, the result is 1, while if two bits are different, then the result is 0, and it is used to compare the XOR result with this subnet mask. Okay, and if the result is all 0, the host is in same subnet, else the packet will be forwarded to default gateway. Okay, so let me copy it and paste it in order to get very sorry, in order to understand what this line we're talking about. Okay, so we were talking about the layer 3 forwarding, how actually layer 3 forwarding works. I must have, and you also must have heard about something called uh, maximum. The method of forwarding using the highest. What was it? Let me ask GPT. Highest packet. No. Highest prefix. Yes, highest prefix. You must have heard that something is of highest prefix. The router compares the different routes to a same address using the highest prefix, and highest prefix it was preferred. So the router uses the XOR and AND calculation computations in order to decide a route. Okay, and if the result is all 0, host is in same subnet, else the packet is forwarded to that way. Let's try to understand this thing again with ChatGPT this time. Okay, so highest prefix. Okay, we are talking about highest prefix in routing. Okay, explain this line using example. Which line I want to explain? I want to explain this line. So, by breaking this thing step by step, suppose we have a source IP address which is this, and we have a destination IP address this. Okay, the source is the incoming IP, while the destination is resulting IP where the packet is to be destined. Okay, and if we XOR it, as you can see, the 1 and 1 counts to 0. Let me increase the font size as well. So 1 and 1 counts to 0, 1 and 1 0, 0 0 is equal to still 0. Okay, and only different things are these last few values. Okay, in this case we can see that the last 5 bits are different, and the result is 1 for those position, indicating that those bits differ from the source and destination. And with this result, this sure result, we are performing an AND operation with subnet mask. Okay, and if the AND result is complete 0, in conclusion, that the address resides in the same network and the packet can be forwarded there. Okay. Next, important thing to be mentioned, that L2 forwarding decides for the exact match, while L3 forwarding decides for the longest prefix. And yes, this is the word that I was hunting for, the highest prefix or the longest prefix. Okay. Next thing, AD and metric are used for route insertion in routing table. So what is AD? AD stands for administrative distance, which defines the believability of route. Suppose the same route is discovered by multiple protocols running on the router. Which protocol will be inserted in the routing table is decided by the AD, while second is metric. If the same route is inserted multiple times by a single protocol, then metric will be used in order to distinguish between which route to be inserted or used in routing table. And actually CCNP put a great deal over the routing table, different types of routing table, forwarding methods, etc. And we will see that. Okay, so a router can have multiple secondary IP address and is useful in subnet migration. Okay, yes, so we can put a command, suppose IP address with an IP address and its subnet mask, and we can put the command secondary in order to have assigned multiple IP addresses on a single interface. Next thing is a directed broadcast message. A directed broadcast message is a message sent to the broadcast address of another subnet, not subnet of the sending host. Okay, I don't know what the use of it, so I will definitely ask GPT, explain the use of directed broadcast message, and it is used to send data to all devices on specific subnet or network. Okay, okay, and here we have an example of it, that also, that we have a network address 192.168.1.0/24, subnet mask which is of 24, I guess, because it already mentions here. Then we have directed broadcast address to one. Okay, when a device itna sends a message to itna, this is a directed broadcast received by all devices within a, but not by outside. Okay, okay, okay. So normally the broadcast is like 255, 255, 255, 255. But in this scenario, we have the network bits set. Hence, it is known as directed broadcast message. Revision is very, very important. Next, we have L2 provides the hop to hop addressing. Hop to hop addressing means that the directly connected device may discover each other, but the devices that are far from one another without any direct connection, without any form of direct connection, because even with a switch we know that it is separated in collision domain. It's a form of direct connection because the switch keeps an eye on what packet will be hopping from here and there. So Next is ARP maps unknown L3 address to unknown L2 address. So ARP is a chat protocol, and by chat it means that it resides neither on layer 2 or neither on layer 3 of the OSI model, but on layer 2.5. Hence, what it does, it maps the known L3 addresses, IP addresses, to unknown L2 addresses, MAC addresses, mostly to find MAC address of the gateway. Okay, and ARP message is directly encapsulated inside of Ethernet header and trigger, which means that the request to learn MAC address for particular IP is specified as target protocol address. What does it mean? ARP message is directly encapsulated inside of Ethernet header and trailer. Okay, which means that the request to learn MAC address for a particular IP is specified as target protocol address. Okay, and okay, so the ARP messages got a special recognition. So it is not like an IPv4 packet or IPv6 packet or an A layer 2 frame. It is directly encapsulated in the Ethernet header and trailer. Okay. In ARPA, which is equal to Ethernet 2, Cisco devices will refresh an entry every time they receive an ARP message from the device, not pings. Okay. Ping is not an ARP message. Ping is ICMP packet. An incomplete ARP entries have an age out timer of 1 minute, while the complete one has a timer of 4 hours. Okay. Incomplete ARP entries have an age out timer of 1 minute. So I'm also started to keep putting spaces between the lines. So it may increase the number of lines, but don't worry, the content is not increasing and we will be going through all of it. Okay. So now the Cisco iOS has a random jitter between 0 seconds and 30 minutes to timeout counter of each ARP entry to prevent multiple ARP entries expiring at same time, causing the ARP storm. Okay. Cisco devices will refresh an entry every time they receive an ARP message from the device. And what time will be refreshed? This is 4 hours. 4 hours. Okay. So let's confirm it. After a refresh, for how many minutes entry remain in table? Let's see. 4 hours, 240 minutes. This was we looking as an answer, and I have already mentioned it here. 4 hours. Okay. Now, what is proxy ARP? Proxy ARP allows a device to respond to the ARP request for the IP address that are it's not its own. It may belong to a different subnet or network. The router checks for the routing table. Okay. And the local proxy ARP is used when the devices are in the subnet or local network. No routing is needed in this case. Okay. Gratuitous ARP is an ARP reply without any request. So announcement when interface is enabled, announcement of change in MAC address, and in case of failover. Okay. So I have written here that when the gratuitous ARP is announced, whenever a new interface is enabled, when there is a change in MAC address, or whenever there is an event like failure, then a gratuitous ARP will be originated and every device will update its ARP, ARP table. Okay. Now we have some commands to proxy ARP globally. No IPR proxy disable in order to enable or disable it. And we do have a few Cisco catalyst here, so we can check that out physically as well. Next thing, different types of static route. Okay, so what are different types of route? First is directly connected, next is recursive, and third is fully specified. Okay, Let's see an example regarding that. Exemplify. Directly connected router that is directly attached to the router and only has an exit interface assigned. Okay. Then we have recursive route in which we have only next IP address assigned and fully specified mentions the both IP address as well as exit interface. And ChatGPT is not doing us very much help here, so let's skip it. Next, this is another most important thing, that clearing ARP table using the command clear ARP does not remove the ARP entry like clear MAC address table, because when you clear MAC address table, it vanishes in an instant. But in case of ARP table, uh, it actually sends a unicast ARP request and wait for 3 attempts to get over after the entry is cleared. So it actually requests the ARP. If it receives a response regarding that, then the entries will not be cleared. And if it won't receive a response at least for 3 times, then after that the entry will be cleared. Okay. Next is MTU. What is MTU? MTU stands for maximum transmission unit. Okay. And quite similar to this, we have three different types of MTU. First is Ethernet MTU, then is IP MTU, and then is TCP MSS. Which this particular thing is a very confusing topic to me as well. So we will study it, we will go through it again and again. Okay. So without any further delay, first ask for the ChatGPT regarding the distinction. Okay. Distinguish between what? First is Ethernet MTU. It refers to the largest size of data frame that can be transmitted over an Ethernet network, including the Ethernet header and trailer. It represents the maximum size of entire Ethernet frame before the fragmentation occurs. Okay. And Ethernet MTU, also known as interface MTU, and it decides the fragmentation. Okay. Ethernet MTU decides the fragmentation. Okay. So typically the Ethernet MTU is 1500 bytes. It includes payload, header 14 bytes, 4 bytes, 14, and okay. And the maximum payload size is 1482. I must have written somewhere. Have I? 1482 copy, and if I control F and find for it, find. Sorry, but I could not find any. Okay. And here we can see that the L2 does not have any fragmentation capability. Don't know what I did there. Bear with me, I will assemble all of this. So we were at Ethernet MTU, which decides the fragmentation. The Ethernet MTU is used by network interface to define the maximum size of data can be sent over the physical link. If the data is larger than MTU, it will be fragmented into smaller frames. Okay. If you are sending a file across the Ethernet network, the Ethernet frame can up to 1500 byte. If the data exceeds it, it will be broken into smaller frame. Okay. Then we have IP MTU, which is refers to maximum size of packet. Okay, transmitted over an IP network, excluding the IP header. Okay. It determines the how large an IP packet can be before fragmentation is required at layer 3, and it is also 1500 bytes, but this can vary upon the network or medium. Some network may smaller or larger IPMTU due to different networking technologies such as 9000 bytes per jumbo frame in Ethernet. Okay. It also defines the maximum amount of data LP layer can send in single packet. If the packet size exceeds the IPMTU, it must be fragmented, dropped. Okay. If you send a packet, then it's 1600. They will break the packets. And TCP, I will further clarify this. Okay, using ChatGPT. Yes, actually, I use for the in terms of classification. I was used to discussing this thing, and it already mentioned all of this. Starting from the start, the IPMTU refers to the maximum size of packet that can be transmitted over an IP network, excluding the IP header. And this is the maximum. TCP MSS is the maximum of application data that can be carried in a single TCP segment. Okay. Okay. Ethernet 1500 and 1460 default. Okay. Data link layer, network layer, transport layer. Entire Ethernet header, payload, trailer. Okay. Their 5 packet, header plus payload. Defines the only the data portion of the TCP segment defines the maximum amount of application data. And next thing is, in essence, these three values define the limits at different layers of OSI model. Okay. The actual size of data excluding the Ethernet encapsulation. What I'm gonna do is to copy this table and paste it here. And it's not looking good in this, but if I zoom out, it may start to look a little beautiful. Nope. Type Ethernet MTU. Okay. IP MTU. Okay. And TCP MSS. Okay. I have to put an enter here. Then we have a type Ethernet MTU. Then we have another type IPMTU, and then we have another type TCP MSS. Maximum size, which is 1500 bytes default, is also 1500 bytes default, and it is 1460 bytes default based on Ethernet. It is an layer 2, layer 3, and layer 4. Okay. Then which includes entire Ethernet frame, header, payload, trailer, and IP packet, header plus payload, and the transport layer, maximum amount of only payload. Okay. Now, the actual size of data excluding the Ethernet encapsulation, remove it. It's not needed here anymore. Cost and trade-off of larger MTU. If you increase the MTU, it will increase the network efficiency because more data can be traveled or transferred per frame. I guess MTU, yes, per frame. Then we have problems like increase of delay, and we have problem of increasing corruption, because more time the signal will be activated, the higher the chance that it will get corrupted. Then we have some frame classifications on the basis of size. We have runs if the frame is under 64 bytes. We have a default which is 1500 bytes. Baby giant up to 1600 bytes. Then we have jumbo frame which is around 9216. And if it exceeds that, then it becomes the super jumbo frame. Okay. Now we have system MTUs, system MTU, system jumbo, system alternate MTU, routing MTU. I don't know what are these. It must be. Let's ask ChatGPT. System MTU for 10 over 100 Mbps interface. The system MTU refers to the default MTU for interface operating at 10 Mbps or 100 Mbps. Okay. Default would be 1500 bytes. Okay. Slower interface, the smaller NTU is standard to maintain compatibility with the majority device in traditional Ethernet network. A router interface of 100 Mbps link may have a default of 1500 bytes to ensure compatibility with legacy system or network that expects standard Ethernet frames. Okay. And for Jumbo MTU is much larger than the standard Ethernet MTU, and it may range around 9000 bytes or 9216, but in particularly. Next we have system alternate MTU, which can be assigned to a particular interface, allowing more flexibility. The alternate MTU value might be used when you need a different MTU on a specific interface. Okay. And then we have routing MTU, routed ports, which are interfaces used by L3 operations rather than L2 operations. Okay, and it is also of 1500 bytes. Okay, what if I put the values in the cute brackets? 1500 bytes, copying it. Yeah. Okay, and system alternative, which is custom. And finally, okay. Next, L2 does not have any fragmentation capability. Let's clarify it. Is it true that L2 does not have fragmentation? Okay. Here why L2 does not handle fragmentation. The L2, one second, let it cook, let it write. Yes, so we were here. Here's why L2 does not handle fragmentation. The L2's role, the data link layer, is responsible for transmission of frames between devices on the same local network or directly connected network. So it is concerned with framing, addressing, error detection, and flow control at the link level. However, it does not deal with breaking up of large packet into smaller pieces when the packet is too large for underlying medium. Okay, so IP fragmentation happens at layer 3. So when an IP packet is too large to fit within the MTU of a particular network segment, it is fragmented by the IP layer before it is transmitted. If the MTU is exceeded, the network layer will break packets into smaller fragments and each segment will be sent separately, each carrying part of the original packet data. Okay. And Ethernet FNAMEs and MTU. Ethernet typically has default MTU 1500 bytes, meaning the total size of the Ethernet frame, including the header and payload, which cannot exceed this value. The data need to be transmitted. Okay. If the packet is too large for the data link layer, larger than the MTU 1500 bytes, the IP layer will take care of fragmentation. If the packet is sent across multiple networks, it is fragmented by router, and layer 2 will handle each fragment as a normal frame without further fragmentation. If the packet cannot be fragmented and DF flag is set, then the IP address will drop if the exceeded MTU link in a path. L2 does not perform fragmentation, it simply handles the transmission. Okay, so does it mean that all all what are this Ethernet MTU, IP MTU, and TCP MSS are handled by L3 protocols? I want to be wrong here in this size, because as per my knowledge, the TCP MSS is handled by layer 4, the transport layer. So let's see what result it will So Ethernet MTU is defined as layer 2 data link layer. It refers to the maximum size of an Ethernet frame, including the Ethernet header and trailer, that can be transmitted over an Ethernet link. The Ethernet MTU typically defaults to 1500. Okay. So Ethernet MTU is handled by L2, but it does not perform fragmentation. It only defines the maximum frame size that can be transmitted. Okay. And if a packet exceeds this, the IP will handle fragmentation. Okay. Then we have MTU, IP MTU, which refers to maximum size of packet that can be transmitted over a network without fragmentation. And I think I just mentioned that the default size of it is 1500 bytes. Okay. If a network of 1500 packet is 1600, the IP will fragment the packet into smaller, which of them fit within the MTU. IP MTU is managed by layer 3 and fragmentation is handled by layer 3 if the packet exceeds the network's MTU. Okay. And TSS, which is a layer 4 transport layer protocol management, which refers to maximum amount of application data can be sent into a single TCP segment, excluding the TCP header and IP header. Is negotiated using the TCP handshake between two devices. The MSS is designed to prevent fragmentation from occurring at IP level. The goal of MSS is to ensure that the application data fits within the MTU of the network, avoiding the need for fragmentation at IP layer. So, for example, on a typical Ethernet network with an MTU of 1500 bytes, the Ethernet frame size will be 1500 bytes. IP header will only be 20 bytes and the TCP header is the typically 20 bytes. Okay, this means that the TCP MSS will be 1460. Okay. Okay. 20 bytes of IP header and 20 bytes of TCP header to fit within the Ethernet MTU. In conclusion, the TCP MSS is managed at L4. It is designed to avoid fragmentation at L3 by ensuring the TCP segment do not exceed the MTU limits of underlying network. Okay. And finally, we got a very good conclusion here. So we are going in reverse in this side. First, we decided that the L2 frame size will be 1500 byte fixed. Then we will decrement the 20 bytes from this, and this will become our L3 packet size. And after that, we decrement 20 bytes, another 20 bytes. Then it will become the 1460 byte of actual data, which comes above and beyond layer 4. Okay. So let's confirm it. So 1460 bytes of data will come above and beyond of L4, right? Yes, very good. So now continuing to our next thing, the frame classification. We already did the classification. We have already discussed the different custom kind of frames. Then we discussed why L2 does not have any fragmentation capability, which is a right thing. Then we have decided the maximum and minimum size of Ethernet frame, which is around 64 bytes to 1518 bytes. Okay, if A22.1Q header is included, frame means including header and trailer. Okay. Then we read about how IPMTU specifies the maximum size of IP packet before it needs fragmentation, and it only applies to layer 3 ports. Okay. IPMTU can be greater than Ethernet MTU, increasing Ethernet MTU. IPv6 MTU is separate value and not native to IPv6 packet. Wait a second. So again, sorry for the interruption, and we will continue this thing. We were at IPv4 MTUs or IP MTUs. Okay. So now the next thing is IPv6 MTU, which is a separate value and is not native to IPv6 packet. It needs the extension in order to provide such features. And in the following series, we haven't discussed a lot about IPv6 MTUs. So I am very much unaware of this. Okay. And we have a few another information that adding up of GRE tunnels add an additional of 24 bytes, 20 bytes of IP header plus 4 bytes of IP header. What is that? I think in here this is GRE header. GRE header. Okay. So if IP packet now needs to be adjusted to maximum of 1476 bytes. Okay. So in the last we have how many size of IP packets? Okay, 1480, 1498 total size of Ethernet 4080 bytes. Okay, plus 14 bytes of Ethernet header. No. Where we exemplify this, or just leave it. Let's compare it directly and try to understand this line. This. So let's say that the original packet or the data is 1500 bytes, which includes the 20 bytes of IP header or 20 bytes of TCP UDP header or the L4 header, L3 header, and the payload, which counts to 1460 bytes. Okay, when you encapsulate this packet in GRE tunnel, you add extra headers. Then the GRE headers will be of 4 bytes, and the new IP header will be 40 bytes. Sorry, 20 bytes in order to encapsulate the GRE packet. Then the total overhead will become GRE header 4 bytes plus IP header 20 bytes, total overhead of 24 bytes. Then adjusting the packet size. After adding the GRE tunnel overhead, the maximum size of the packet need to fix a new MTU, taking the amount of additional 24 bytes. The standard MTU, which is of 1500 bytes, but since the GRE tunnels add 24 bytes to the IP packet and including the GRE and IP header, which should not exceed 1500 bytes. Therefore, the new segment size of the original packet becomes 1500 byte minus 24 bytes, which is equal to 1476 bytes. Okay. So since the original IP packet need to fit within 1476 byte limit, the application data will need to be adjusted, which is a very normal thing to do. And what do we have key takeaways? That the GRE tunnel add 24 bytes of overhead and 4 bytes of GRE header. As a result, the maximum level size for the IP packet is reduced from 1500 to and this is called this thing. Then we have PMTUD, which stands for Path MTU Discovery, which is an ability to dynamically discover the lowest MTU value in the path to destination in order to avoid the fragmentation of IP packets, because fragmentation is a not good thing. Okay. Then we switch to a new thing, and we have a community link here, Cisco community link. Let's see. Oh, I keep pressing the wrong buttons. Which regards to the configuration of GRE tunnel, and it's a quick thing. Let's see. So the window size determines how much data can be received within a span of multiple segments before sending an acknowledgement. Okay, suppose window size is determined as after every 4 or 5th segment, we just want an acknowledgement that you received the previous 4, and this is in simple words, this is the window size. Okay, and MSS, which stands for the maximum segment size, is the maximum size of the TCP payload, not the header, not the trailer. Actually, TCP don't have a trailer, so not the header, only the payload is the MSS, which includes the which exclude the L2 information but includes the L3 information and determines the maximum amount of data a host can receive in a single TCP segment. Okay. the MSS IPv4 default 536 byte. Okay. 536 MBs payload, 20 bytes of data, 20 bytes of TCP header, which is 576 bytes of IPv4 datagram, and 20.7%. Okay. I wanted to re understand MSS again in terms of size. Okay, so MSS is equal to MTU minus size of the IP header, okay, minus size of the TCP header. Okay, so if we have MTU, okay, so Ethernet MTU is 1500 bytes, IP header is 20 bytes, and TCP is of 20 bytes again. Okay, so 1500 minus 20 minus 20, which comes to 1500 minus 40, which is around 1460 bytes. Okay, 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 which is in case of GRE. Then after that, what is the IPv4 default MSS? Because I just wanted clarification that what I written here. Let's see. The default MSS for IPv4 typically what MTU is the network, particularly for okay. Then we have a 1460. Okay. The default MSS for IPv4 over Ethernet is 1500 bytes of MTU is 1460 byte. Okay. And what about IPv6? Great question. The calculation is similar to IPv6. Okay. So Ethernet MTU still is 1500 bytes. IPv6 header, which is of 40 bytes, which is larger than the 20 byte, and TCP header is still 20 bytes. So the MSS will become 1440 bytes. Okay. So I think these the things that I written here is rubbish and does not actually mean something. So I deleted it. Okay. And Cisco IOS will confirm the lowest MSS value of the link. Next, Cisco IOS devices specify an MSS of 1460 to the local network and MSS of 536 to the remote network. Wait a second, there is something mention of 536. Let's ask it. Is it true? And why? Yes, it is true that Cisco is default specify an MSS of 1460 byte for local while Itna for remote network. Okay, and here why? Because it's in the MTS. Okay, and for remote network. Okay. Primary reason is to avoid fragmentation. They have also set a smaller value. Okay. So okay. 576. Okay, got it. Got it. What happens in practice? Okay, this device assumes that the MTU is 1500 bytes and advertise an MSS of 1460 for TCP connection. Then connects to a remote network. It lower MSS by 536 bytes to accumulate links with potentially a smaller MTU to prevent fragmentation. Okay. and yes, it allows the values to be adjusted, which is a great thing. Now, the TCP header is a part of L4 OSM model, while the IP header is L3 OSM. We already written it, so I'm erasing this. Now, this heading of MSS only affect the PDU originating from the router, as the router does not work at transport layer, so it ignores the MSS value for the regular traffic. And what does it mean? The setting up of MSS only affects the PDU originating from the router. Importance of concept about how MSS and routers interact. Okay, the MSS defined in L4. Okay. When MSS is configured on router, typically affects the TCP connection originating from the router itself, which means that the okay. Router do not also regular traffic. Now I get it. Router does not work a transfer originating from the router, uh, such as connections made using SSH or telnet. As the router does not work for transport layer, regular traffic. Okay, so the router, when router itself initiates a connection, then it will adjust the MSS value by the command that we just written IP at TCP adjust this. But for regular traffic, this command is not validated because the device originating the traffic will validate. So when the router becomes this server for something, for example, an SSH server, then the values of MSS will be taken care of. Okay. Next thing, path MTO discovery. PMTO allows the host to determine the maximum packet size used along the path. Okay, I think I have written it somewhere. Okay. And finally, the MSS adjustment are done on per interface basis, and the GRE header consists of its own IP information, hence 20 plus 4 in order to prevent fragmentation. Okay. So as the video has already been around 52 minutes, so this is a slight pause in the video, and the video will be continued but in next section. So if you are continued watching it and if you loved it, I hope sure that you will be there in the next video. So that's still on for this video. See you in the next one.